This is the Interlock Industries Resistance Welding Controller Model 108. Designed as an upgrade of the Model 105 microprocessor welding control, the Model 108 offers the same ease of use along with many new added features. This training tape is made up of 4 segments. The first is a brief overview of the Model 108 and how it works on the inside. The second will cover the basic programming steps involved in setting up and executing simple weld schedules. The third takes a look at some of the auxiliary features of the Model 108, such as weld and forge pressure programming, forge delay time programming, motor speed control, and RS-232 PC communication. The last segment of this tape explores the advanced programming steps for chained and successive modes. At the beginning of each segment, a large segment number and title will be displayed for 5 seconds. This way, if you're fast-forwarding, you'll be able to see the segment heading and hit the play button on your VCR. If your VCR is equipped with a time counter, you can use the time indexes in this table of contents to fast-forward directly to the segment you are interested in. The Model 108 has the ability to store 300 complete weld schedules. It can also operate in chained or successive modes for more complex parts requiring a series of weld schedules to be linked together and then repeated. Like the Model 105, the front control panel of the Model 108 is made up of 3 basic sections. A 2-digit LED numeric display that indicates the weld schedule and numeric data of the weld parameters you are currently working on. A series of individual LED lights to indicate which programming parameter you are in each step of the way. And a phone-like push-button keypad to enter the numeric data for each programming step. In addition to these 3 main sections, there is a new switch to pay attention to on the Model 108. Located toward the top of the control panel just under the successive LED is a toggle switch labeled simply A, B, and C. This switch is used to select one of the 3 memory groups into which you can program 100 separate weld schedules. All weld schedules are numbered from 00 to 99. So for instance, Group A can have a weld schedule 05, and so can Group B and also Group C. Each weld schedule in each group will be completely different, but will look the same in the numeric display window. You will need to look at the position of the toggle switch to see if you are in Group A, B, or C. The first thing you will notice when you try to open the door is the safety locking system. When the Model 108 is powered up, a small electric solenoid pushes a pin through a locking hole attached to the door frame and won't allow you to open the door. Until the main power to the unit is turned off, the door will not open. Once you have powered down the unit and you have the door open, you can see the inside of the Model 108 is really made up of 5 basic areas. The board attached to the door just behind the front panel is the processor board, and is also known as the brain board or front panel board. It processes the data that was input by the operator from the front panel. The information is then sent down this ribbon cable to the peripheral board. This is the part of the controller that talks to the welding machine. It tells the valves and weld cylinder piston how to move the electrodes together or apart. Another important part of the system is the AC contactor. This is an electronic switch connected between the power line and the welding transformer. Its job is to control the power being sent to the welding transformer, which then generates the current used to make the weld. The snubber, bundled with the AC contactor, is used to chop and clean the AC line to prevent the contactor from activating on its own. The AC contactor is being driven by the firing module. The microprocessor on the front panel board sends signals to the firing module, which tells the AC contactor when to turn itself on and off. The system power used to operate the low-voltage components inside the Model 108 comes from the power distribution transformer, which is located just above the firing module. This transformer takes the incoming line voltage, which is typically 480 or 220 volts, and converts it down to the voltages needed to operate the microprocessors and AC contactor. The Model 108 can be set up with different transformers to work with the many line voltages and line frequencies in use around the world today. There are two modes of initiation for the 108 welding controller. These are typically set up at the time of installation. They allow you to choose your method of initiation schedule. The first method is via a single or two-stage foot switch. The second is called anti-tie-down mode. When using the anti-tie-down mode, there are two ways to initiate the weld with the palm buttons. The first is called momentary push. This means the operator pushes the palm buttons simultaneously to start the weld, and then can let go of the buttons, and the weld schedule will finish and then exit to standby. The second setup is called push and hold. This requires the operator to simultaneously push and hold the palm buttons for the entire weld schedule. If the operator runs during the weld schedule, the weld will stop and the electrodes will release. At the time of installation, to set the Model 108 for one of these modes, open the controller and find switch block number 7. This is a blue block in the front panel board. Place switch 7 number 1 in the on position for momentary push, or switch 7 number 2 in the up or on position for push and hold. Make sure you don't have both of these switches on at the same time. Another method of weld initiation is to select a weld schedule in Group A, B, or C by using 3 independent foot switches or dual palm buttons. A set of switches is assigned to each group. When the operator presses the foot switch or palm button for Group A, the appropriate selected in that group will be initiated. To use this method of operation, place the Group Select toggle switch in the B position and press the appropriate foot switch or set of palm buttons. Keep in mind, change from group to group, the weld schedule number will remain the same. Now, let's close the door and reactivate the system. Remember, if the foot switches are closed when you return power, the Model 108 will freeze up and display 88 in the LED window. Don't worry, this is not a malfunction. It is, in fact, another controller function designed to alert the operator that the foot switches are closed at the time electrical power has been applied to the welding machine. For safety reasons, this is not allowed. Simply turn off the electrical power, open the foot switches, and then reapply power. The unit is now back to normal operation. Now let's move to the front panel and go over the basic steps for programming a single weld schedule. Here are some basic functions of the keypad and the displays on the front panel. Looking at the keypad, you'll notice it's much like the pad on your touch-tone phone at home, only where the pound key is, there is a red key instead. This red key is used to enter into the weld schedule the data you have punched in on the keypad. After you push the red key, the data is entered and you are advanced to the next step in the programming sequence. To input a number or value for a particular step, simply punch in the number just like dialing your phone. Almost all the values to be entered are between 00 and 99. The values are based on cycles or heat percent. In this case, we are using cycles of electricity, which is 60 cycles per second in the United States. One positive and one negative swing of the electrical current equals one complete cycle, or 1/60th of a second. The microprocessors in the Model 108 are all based on this system of time, so therefore all calculations are based on a 60th of a second, or one cycle of electricity. Heat percent is measured in fractions of a cycle, allowing more precise control over the temperature of a weld. The keypad also has a star key in the lower left corner. This key is used to put the welding controller in the standby mode. Standby mode is indicated by all LEDs in the vertical row turned off and the LED display showing the number of the weld schedule in use. Standby is the mode you want to be in when starting a new weld schedule. Also, if during programming you want to jump to the beginning of the weld schedule, push the star key and you will be immediately taken to the standby mode. As you scroll through the sequence of programming steps, the vertical row of LEDs along the left of the keypad will individually light. These indicate which function is related to the 2-digit number in the display window. As you program a weld schedule, you can also go back to the beginning and advance through each parameter to check its entered value. Do this by pushing the star key, which puts you in the standby mode at the beginning of the schedule. Now push the red key to scroll through each of the steps. Watch the row of vertical LEDs to see which step you are on. If you want to modify a particular step, simply scroll to that step. Then input the new value and push the red key. This will enter the new value, replacing the old one, and advance you to the next step. After you have made your updates, you can continue through the weld schedule or exit to standby with the star key. Let's set up a basic weld schedule. First, set the Group Select toggle switch to Group A. Now you should be in the standby mode. From here, key in a new weld schedule number. For example, let's use 01. Press the red key once to move from the standby mode to the first function in the programming sequence. The red LED for squeeze delay time comes on. This function is normally not used in a non-repeat weld sequence and will indicate a 00 in the display window. Press the red key again and the LED for squeeze time lights up. Squeeze time is the time it takes the electrodes to move toward each other pressing against the part to be welded. A typical value is 25 cycles. So let's input the value 25 and enter it into our weld schedule. Now press the red key to advance to the next function. Impulses would be your next stop. This function or step is a little more involved. Impulses equals the number of impulses entered times the sum of cool time plus heat time. Okay, now in English. Notice there is a white line on the front panel connecting the 4 LEDs or functions: impulses, cool time, heat time, and heat percent. All 4 of these steps interact with one another. It works like this. The first value that you input is the number of impulse cycles. Each impulse cycle indicates 1 pass of cool time and 1 pass of heat time at a given heat percentage. You could say each impulse is a subloop in the overall weld schedule. The impulse step is indicated by the red LED labeled impulses. Let's input a value of 2 impulses. Now press the red key to advance to cool time. Cool time is used if more than 1 heat impulse is required to fully make the weld. Cool time allows the weld nugget at the center of the weld to cool properly before it's reheated on the next impulse. Input 2 cycles. Press 02 and advance to the next function with the red key. Heat time that heat is being applied to the weld point at each impulse. We'll use a value of 15. Heat percent is the last of the impulses group. This value is the amount of heat applied to the weld. If we input a value of 50%, the power applied to the weld will be 1/2 of the full intensity. If the number 25 is input, the heat would be approximately 1/4 of full intensity. Let's put in 50 as our heat percent for this weld schedule. Both the heat percent functions can be accessed directly with their own keys. If you are in the standby mode and want to adjust the heat time, just press the green key and input a new value. After you have input the value, push the star key to go back to the standby mode. Quench time allows the weld nugget to cool after the weld is made, and a quench time of 15 cycles. Temper time and temper percent are used with some metals and alloys to cool them more slowly, which prevents cracking. The values are keyed in the same way as heat time and heat percent. 5 cycles of temper time at a temper percent of 20. Hold time the electrodes stay together after a weld is made. It allows the material to cool before the pressure is released. Typical hold time is 20 cycles. So let's enter 20 followed by the red key. Mode off time should be programmed from 1 to 99 cycles. This allows the electrodes time to separate. You can then position the material for the next weld while the foot switch is still held closed. In this example, set a value of 60 cycles, which is equal to 1 second. At the end of off time, the controller automatically will advance to squeeze time to repeat the sequence. Repeat mode allows the operator to perform multiple welds on the same part while holding the foot switches closed. To turn on, simply switch the repeat switch to the on position. When the operator starts the weld schedule, the 108 will repeat the same weld schedule until stopped by releasing the foot switches. Upslope percent per step need to be set to 0 when not in use. The upslope function controls the rate at which an increase in heat is applied to the welding electrodes. This is a gradual increase in current that reduces expulsion and splatter. Upslope is recommended for materials that require initial progressive heating. To program the correct heat increase, use the following formula. Ending heat percent minus starting heat divided by upslope steps will give you the percentage of heat per step that you will need. Let's look at an example. If your ending upslope heat will be at a strength that is 80% and your starting upslope heat is at 40%, then the formula says 80% minus 40% equals 40%. Now, divide that by 8 steps and it equals a 5% increase for each step. It is now pretty simple to program the upslope steps into the welding schedule, since we have figured out the amount of heat percent per step. We have a starting heat time at 20 cycles and a starting heat percent at 40%. Use the green and red buttons along the left side of the panel to input the heat time and the starting heat percentage directly into the weld schedule. Scroll through the functions using the red key on the keypad to upslope steps and input a value of 8 steps. Next, scroll to the percent heat per step and input the value that we calculated of 5%. If you look closely at the display, you'll see there is a decimal point between the two digits. This is so you can input a more precise number for heat percent per step. This can be a number from 0.1 to 9.9. So now, if we run this weld schedule, the welder will start at 40% of the total heat intensity, then step its way 8 times up the 80% at a rate of 5% per step, and then finish its remaining 12 cycles of heat time at the 80% intensity. Now, let's look at some of the other features of the Model 108 welding controller that make it the right tool for any welding shop. A butt weld means joining 2 pieces of material with a flat edge. Typically, the material is round stock. Piston rods from the landing gear in airplanes is a good example. To put the welding controller in the butt weld mode, set the mini dip switch S5 number 4 inside the welding controller to the on position. This is an orange block in the middle of the board. Make sure switches 1, 2, and 3 are in the down or off position. Anytime you're changing the setting of these switches, the power to the controller needs to be off. With stage foot switch, applying stage 1 clamps used to hold the material in position for the weld. Reposition the parts, let up on the first stage foot switch, and then depress the first foot switch again to reclamp. Next, depress the second foot switch to act time and to lock in the controller and activate the upset valve. From this point, the weld schedule will run automatically through heat time, hold time, and off time. At the end of hold time, the upset valve will release. Then at the end of off time, the clamp valve will release. Now, the 108 exits to the standby mode and is ready for the next weld. To program a butt weld, use the following steps. Squeeze delay time is the time for the 2 clamps holding the parts to close prior to initiating the upset valve. This should be set for the appropriate time for the clamps to close. You may need to experiment with this a little. We'll put in 40 cycles. The upset cylinder forces together the 2 pieces of material being held by the clamps. The squeeze time is equal to the upset time when programming a butt weld sequence. Let's use 10 cycles. Heat time and heat percent set the temperature levels for an acceptable weld. Hold time is used to hold the parts under pressure until they are cool. Off time is the time required for the clamps to open so the material can be removed. Here are 2 modes that come in very handy: seam and roll spot modes. These 2 features are optional upgrades to the standard Model 108 welding controller. They require additional relays to be installed, as well as a 2-position switch in the front panel used to select between seam and roll spot. To operate in either seam or roll spot mode, set mini-dip switch S5 number 2 to the on position inside the 108. And on the front panel, set the toggle switch labeled Seam Roll Spot up for the seam mode or down for the roll spot mode. In seam mode, the welder has 2 copper wheels instead of copper electrodes. One of these wheels is motor-driven to move the material being welded. This is used for overlap seam welding. Using foot switches, the first stage foot switch energizes the squeeze cylinder, 2 wheels together which hold the parts to be welded. The second foot switch starts the motor controller and continues through a cycle of cool time and a cycle of heat time until the second foot switch is released. Then the weld controller will enter hold time, then off time, and then exit to standby mode. There can be X number of cycles of cool time and heat time individually. The impulse counter should always be set to 1 impulse. To program a seam weld, you will first need to enter the motor speed. Push *7 to enter the motor speed function. Now input a number from 00 to 99. These values are a percentage of maximum speed. In this example, we will use a value of 10. So the motor will turn at about 1/10 of its fastest speed. Next, program in the squeeze time. Let's use 25. Now, impulses 0, 1. Heat time and heat percent are used to set the levels for an acceptable weld. We'll use 6 cycles at 40%. Cool time. Cool time together with the motor speed sets the overlap distance between the 2 spot welds. This may take a little experimentation to fine-tune your weld. Cool time, 2 cycles. The last step in this weld schedule is setting the parameter for off time. Off time may be set to 00 because it's not used in seam welding. Roll spot is used to create a seam weld when the material is stationary and the welding wheels are not moving. This type of weld is done when the materials require forge pressure. The weld controller will execute a weld spot in the same fashion as a standard spot welder. During off time, the motor which spins the wheels will turn on for the duration of off time, moving the part to the next position to be welded. In this mode, the overlap distance between 2 welds is determined by the motor speed and the duration of off time. Let's program a simple weld schedule for a roll spot. From the standby mode, scroll to the impulses parameter. Enter a value of 1 cycle. Now our usual parameters. Cool time 0 cycles, heat time 10 cycles, heat percent at 50. Hold time in this case is to cool the weld before indexing or moving the part. So we'll use a value of 6 cycles. Off time is used to move the part, in this case not that much. Based on a predetermined motor speed, let's input 20 cycles. And now we have a roll spot weld schedule for the Model 108. It's that simple. Now that we have the basic programming steps down, let's take a look at some of the auxiliary features of the Model 108 welding controller. Weld pressure and forge pressure are similar functions offered in the auxiliary modes of the Model 108 welding controller. They give the operator the ability to control pressure applied to the electrodes during a weld schedule. Once the pressure is set in the schedule, it can be saved and recalled with the other data every time that weld schedule is used. To program a value for one of these functions, simply push *4 for weld pressure or *5 for forge pressure, and then enter a 2-digit number using the keypad. Use the * key to exit back to the standby mode when you're done. After you've entered the pressures, look at your pressure gauges and verify that the pressures entered in the controller are equal to the ones shown on the respective gauges. Forge delay time is entered by inputting a value in the function parameter for a *8. As the Model 108 enters the first weld impulse after squeeze time, forge delay time is started simultaneously with the beginning of the first impulse. The Model 108 can be equipped with an auxiliary board which allows the connection of a personal computer via an RS-232 port in the back of the cabinet. This gives you the ability to transfer weld schedules back and forth from the 108 to your computer for storage and editing. For a detailed explanation of setup and programming with your computer, please see PC to Model 108 RS-232 communication in the reference manual. Some of the advanced programming techniques include cascade mode, chained mode, successive mode, and manual valve select. Cascade mode is a sequence of weld schedules that turn on, sequentially, 3 welding guns or 3 welding transformers, 1 per weld schedule. This is used to make multiple welds on the same part. There are 2 different cascade modes, chained mode and successive mode. We'll go over mode selection in a minute. First, let's look at how to switch the Model 108 into the cascade mode. To turn cascade mode on, you have to open the 108 welding controller and on the processing board, go to the switch labeled S5. Mini-dip switch number 1 needs to be in the up position, which is on. Normally, this setting is made when the welding controller is installed and does not need to be adjusted again. Now you are ready to operate in the cascade mode. Cascade mode works in groups of 3 weld schedules. So you can cascade weld schedules 1 through 3, then 4 through 6, then 11 through 13, and 14 through 16, and so on. Weld schedules 1 through 3 correspond to valves 1, 2, and 3 directly. The clamp valve will stay on from the beginning of the first weld schedule through the last weld schedule in the selected group. Now, let's talk about chained mode. This means that once the first weld schedule in the group is activated, all subsequent weld schedules in that group will automatically be activated in their proper sequence. To set up a chained mode, key in *1 in the standby mode. The LED under the word chained will light up, indicating this weld schedule is chained or linked to the next weld schedule, and it will automatically be activated at the end of the first weld schedule. You need to use *1 each time you want to chain weld schedules from one to the next. So, from weld schedule 2 to 3, you would be on schedule 2 in the standby mode and then press *1. This chains 2 to 3. With schedule 3 being the last weld schedule in the chain and not being linked to weld schedule 4, make sure you don't turn the *1 LED on. At the completion of weld schedule 3, the controller will return to weld schedule 1 in the standby mode. The same holds true for weld schedules 4 through 6, and so on. The last weld schedule in the sequence does not have to have the chained LED on. If you want to turn the chained mode off, simply key in *1 again, and the chained LED will turn off, indicating that the weld schedule is no longer chained to the next one. Weld schedules with the least significant digits 1, 2, and 3 will operate squeeze valves 1, 2, and 3, or transformers 1, 2, and 3. Manual valve select allows the operator to choose 1 through 5 valves in any combination for use in a specific weld schedule. To activate this mode, open the Model 108 controller and find switch block number 7 toward the bottom of the front panel board. Put mini-dip switch number 3 in the up or on position. Now, from the standby mode, push *9. The display will show the value of 10. By pushing the red key, the number will increase by increments of 10 at a time. The left digit in the 2-digit number points to the valve being programmed. The digit on the right indicates the operating status to be programmed for the valve. Let's select valve 1. Push *9. Number 0 indicates the valve is not active. Change the number from 10 to 11. 11 or 11 indicates that valve 1 will be active from the beginning of squeeze time through the end of hold time. Now change the number to 12 and valve 1 will now be active from the beginning of squeeze time to the end of off time. Now let's try 13. This will cause valve 1 to be active only during off time. After selecting the operation mode for all 5 valves, push the * key to return to the standby mode. The *9 LED will turn off, indicating that the selection mode is completed and you are now in the standby mode. Programming of all 5 valves in the manual select mode is relevant only if the welding machine is equipped with 5 valves. The Cascade Successive mode operates in a similar fashion to the chained mode. The difference is that in the successive mode, the controller will stop at the end of the off-time step of every weld schedule programmed in the Cascade sequence. A new initiation or palm buttons will be needed to advance to the next weld schedule in the group. To create a link between two welds in the successive mode, the star 2 LED must be lit. To do this, press star key and then the 2 key while in the standby mode. This needs to be done in the first weld in the group schedule to be linked. Programming and activation of valves and transformers in the successive mode is identical to the chained mode. The Model 108B welding controller is similar to the standard 108. It allows you to have control over a variety of welding parameters commonly used today. Some of the new features added to the Model 108B are weld operation in 3 modes, open loop as in the standard 108, automatic voltage compensation known as AVC, and constant profile current. Some of the other features are 8-valve or relay control AC outputs, 6 welding transformer firing module outputs, 8 conditional instruction limit switch inputs, and manual welding transformer select. Let's take a closer look at some of the parts inside the 108B that make it different from the standard 108. The front panel or brain panel has a few more cables running in and out of it. The microprocessor has been upgraded to handle more data quicker. The peripheral board in the 108B is now referred to as the Extended Function Peripheral Board, and is where most of the changes have been made. As you look along the board, you'll see the added positions for firing modules, valve relays, transformer controls, and limit switches. If you look closely, you'll see there are a series of blue blocks throughout the board with adjustment screws in them. These are potentiometers, which are preset at the time of installation. They are used to calibrate the AVC and constant current features that have been added to the Model 108B. We'll talk more about how to use these in a minute. Toward the bottom of the board, there are 2 groups of LED lights that indicate which valves and transformers are in use in a given weld schedule. Along the left edge of the board are the connections for the additional firing modules and the valve controls. Then on the right side are the terminal strips for the limit switches and the current transformers. Another important item to point out on the peripheral board is the high-low limit weld cylinder pressure sensor. This is located at the top of the board. The 2 hoses wrapping around the back of the cabinet allow you to connect an air pressure sensor to measure differentially the pressure of the upper and lower chambers of the cylinder. These measurements are made at the end of squeeze time and are set to work in a range of plus or minus 1 psi. If the correct pressure is not read by the sensor, the weld will not be allowed to start. The high-low pressure feature is also available on the Model 108BLD. The standard 108 can also access this feature when an auxiliary board is installed. The 108B, as well as the standard 108 controller, can be programmed with a weld pressure and forge pressure level in each weld schedule. A range from 1 to 99 psi can be entered using the star 4 and star 5 keys. The way this works is the controller generates an electric signal, which is read by 2 electric pilot pressure regulators. These pilot pressure regulators produce a pilot pressure of 10 cubic feet of air per minute, or CFM, which is fed through a 1/8 inch plastic hose to the input of an air volume booster. This volume booster increases the CFM capacity to a level of 45 to 150 CFM, depending on the model chosen for the specific welding machine. The pilot pressure regulators are located at the rear of the weld controller cabinet and are factory calibrated. Now, let's look at some of the specific upgrades of the Model 108B. Manual valve select has been expanded to offer a total of 8 valve outputs. This function is programmed just like the standard 108. To access this function, push star 9 in the standby mode. Now the number 10 is displayed in the LED window. The first digit, 1, indicates the valve you are programming. In this case, valve 1. The second digit, or least significant digit, indicates the operating mode currently entered for that valve. For a detailed explanation of the 6 different mode selections, please look at page 15 in the operator's manual. The amount of outputs to drive welding transformer firing modules has been increased from 3 to 6. To enable use of the manual transformer select, you need to put switch SW7 number 3 on the brain panel in the up or on position. This is typically done at the time of installation with the electrical power off. You are now ready to program the transformer select function. From the standby mode, push star 7. This enters you into manual transformer select. Now enter a number from 1 to 6 to indicate the transformer you are selecting and program the rest of your weld schedule as you normally would. The Model 108B also allows 2 repeat functions that are pretty handy in relation to the transformer select function. Star 2 will allow the controller to repeat that specific weld schedule in the chain as many times as you enter. So let's say you were programming a chain of 1 through 6 weld schedules and wanted to schedule 3 to repeat 2 extra times. In the middle of the chain, you go to weld schedule 3 and use star 2 to enter the repeat weld schedule function. Then you input 2 for the number of repeats you would like for weld schedule 3 in the chain. When started, the chain will go from 1 to 3, then repeat schedule 3 2 more times, then move on to schedules 4 through 6 to complete the chain. There is also a group repeat function. By using star 3, you can repeat an entire sequence from 1 to 99 times. You need to enter this mode in the last weld schedule in the sequence, and then input how many times you would like the sequence to repeat. It's really that simple. Limit switch conditional instructions is a feature that is very useful. It allows you to assign a specific reaction to the closure of a contact switch placed somewhere on the welding path. You can have up to 8 switches. These can be used to tell the welding controller when a part is in place or is out of alignment. The controller then executes the specified command programmed for that limit switch before continuing the weld schedule. For a list of the limit switch instructions, please see page 19 of the operator's manual. 2 of the biggest upgrades in the Model 108B are automatic voltage compensation and constant profile current. These are used to minimize weld current variations caused by power line voltage fluctuations and current changes when welding large sheets of steel in a deep-throated welding machine. Automatic voltage compensation, or AVC for short, works with the incoming line voltage and the preset percent heat function entered in the weld schedule to keep a constant voltage output to the welder. By adjusting the percent heat value to offset for a fluctuation, the welder never sees a change in its incoming voltage. The objective of constant current profile is to maintain an equivalent RMS current average for each weld. It uses as a reference a sample weld that has been qualified as an acceptable weld at the time of calibration. It needs to be remembered that for the 108B controller to exit the open loop operation, as in the standard 108 controller, the switch SW1-3, located on the extended function peripheral board, needs to be turned on. Again, this is done typically at the time of installation. This will put the controller automatically in the AVC operating mode. To take a weld sample, which will be stored in the controller memory associated with that particular weld schedule, push star 3. The LED labeled star 3 will flash, indicating that the controller is ready to take a weld sample and make a weld. Observe that the star 3 LED stopped flashing and changed to a solid. This indicates that an RMS profile current has been stored in the computer memory. Make a destructive test of that weld to qualify it as acceptable. If the test is not acceptable, push the star 3 key on the front panel to turn the star 3 LED off. Change percent heat parameters up or down, then push star 3 again. The star 3 LED will flash, indicating that it is ready to store another current value. Make a weld and test its quality acceptance. If acceptable, the current value will be stored forever with that weld schedule. Whenever you go back to that weld schedule, observe that the star 3 LED is on. In order for the controller to regulate the current under worst line voltage conditions, it is recommended that the sample test be done at a percent heat level not greater than 70%. In the event that a large part is to be welded, make the sample test with the whole part in the welding machine throat for best results. For detailed instructions on AVC and CPC calibration, please read pages 28 and 29 in the operator's manual. The 108B is equipped with two modes of weld current checking. The first is alert-only mode. This mode does not stop the weld schedule, but will alert the operator that the weld schedule has fallen out of acceptable parameters for the values entered. By using the star 6 function, you can key in a value between 1% and 20%. These numbers represent the amount of acceptable deviation from the current profile that will be allowed before alerting the operator. The second mode is halt mode. It operates just like the alert mode, but instead of alerting the operator, it will automatically stop the weld schedule and display a number in the LED window. This number indicates the percent of deviation from normal that was detected in the weld. Set the controller, release all foot switches, the star key. The Model 108 BLD is not that much different from the Model 108B. The LD stands for load distribution. This means two things. The BLD is capable of using three-phase power instead of single-phase, and that it can evenly distribute it across more transformers. By adding a load distribution board to the extended function peripheral board, there are now a total of 12 transformers available. This new board also adds 8 more valve relays, giving you a total of 16 to work with. To select 6 or 12 transformers for activation, open the 108 BLD and check the position of jumper number 1. It's located at the top of the load distribution board and is labeled JP1. With the jumper in place, transformers 1 through 6 will be activated. If the jumper is open or empty, then transformers 1 through 12 will be activated. Please see page 12 of the operator's manual for a complete list of transformer combinations. To switch the Model 108 BLD from single-phase to three-phase operation, place a jumper in the JP2 position on the load distribution board. Now, the BLD will distribute the welding current across the transformers evenly. With the BLD controller, you have up to 16 valves to choose from. To access the first 8 valves, push star 9, just like on the 108 and the 108B. To access the second set of 8 valves, you need to push star 9. The star 9 LED will now flash twice as fast as before, indicating that you are now entering the data for the A group or second set of valves. The data enters the same way and is stored for valves 9 through 16. If you feel you are having a problem with one of the valves or limit switches, the BLD has a diagnostic light display on the extended function peripheral board designed to help identify which relays are on and at what time in the weld schedule. If you look at page 33 in the manual, you will see a layout for the light modules and their appropriate valves or limit switches. One of the other features of the 108 BLD is the ability to connect a weld counter to the controller. Via a relay located on the load distribution board, a mechanical weld counter solenoid can be hooked up to keep track of the number of welds completed. Turn to page 23 for the installation instructions regarding the counter. We hope this information helps you to better understand the operation of the Interlock Models 108, 108B, and 108 BLD welding controllers. We think the use of this tape, along with the operator's manual, will get you on your way to controlling weld schedules and projects in the shortest time possible. Thank you for watching this Interlock instructional video.